Underground cables digitization, UG. Underground network includes the electrical cables buried under the ground along with connected electrical assets constructed above ground. The main underground cables are connected between the electrical equipment such as substation, distribution boxes and meter boxes, etc. As per our GIS project requirements, we need to digitalize the entire distribution network, which includes both MV and LV underground network, which is based on the company-provided inputs such as as-built, CAD drawings, SLD, and hardcopy maps. We shall use ArcMap application to digitize underground network and will implement below workflow/process to achieve quality data. We have used SEC-provided vector base map as reference to create the UG network with SEC digitization standards. We have followed the shape of GIS parcels data provided by SEC to represent the network route and maintain the offset from the same parcels. We found there are some UG cables are crossing the parcel boundary when the substations/distribution boxes are inside the parcel or surveyed service points are inside the parcels. SEC agreed these crossings are acceptable. We have found there are few service connections directly taken from substations instead of from mini pillar or poles. The same connected to LVDB areas internal assets accordingly. Underground digitization is briefly categorized in two phases. MVUG, medium voltage underground. LVUG, low voltage underground. Source require for underground digitization. As-built converted GDB, provided by client, the GDB converted from as-built. This is the reference GDB, we need to follow the routes of the cable. Refer. Picture 1. Satellite imagery, use ESRI basemap. Refer. Picture 2. Parcel data, provided by client. Refer. Picture 3. Note, check the parcels with respect to imagery. If there is any conflict, inform the client through references and get it solved before starting the UG digitization. SLD, single line diagram provided by client. Refer. Picture 4. MV_UG medium voltage underground digitization. MV-UG lines are used only in between grid stations/substations and substations. MV_UG lines are captured by using the reference GDB, as-built, and SLD. MV-UG cable will be digitized by taking offset from parcel/row edge based on the street/row width. See below are the different conditions for applying offset for MV-UG cables. Case 1, street row width is more than 10 meters. If the street width is more than 10 meter, first MV cable should be digitized at 5 meter distance from parcel boundary. Additional MV cables needs to be digitized by maintaining 0.25 offset from first MV cable towards the street center line. Picture 5. Case 2, street row width is less than 10 meters. If the street width is less than 10 meters, then we need to identify the center offset for the first MV cable, which is 0.25 meter below the street center line. i.e., if the street width is 8 meters, then first MV-UG cable should draw at 3.75 meter, refer, picture 5. Additional MV cables needs to be digitized by maintaining 0.25 offset from first MV cable towards the parcel boundary. Picture 6. Case 3, street row width is less than 6 meters. If the street width is 6 meter or less, draw the MV-UG cable first, below the street center line, if any, and then digitize the LV-UG cables below the MV-UG cables towards parcel boundary. If there is no MV-UG cable in a particular location, then start the LV-UG cable next to street center line. In most of these cases, MV lines are not available since these are all small streets and not a major road, since MV network will not available. Select the MV-UG segment with respect to primary voltage of transformer for digitization as showed in picture. Picture 7. LV-UG, low voltage underground digitization. LV-UG lines are used only in between substation to distribution box, and distribution box to customers. LV_UG lines are captured by using the reference GDB, as-built, and survey photos. LV-UG cable will be digitized by taking offset from parcel/row edge based on the street/row width. See below are the different conditions for applying offset for LV-UG cables. Case 1, street row width is more than 10 meters. Digitize first LV cable at 3 meters distance from parcel boundary. Additional LV cables will be digitized next to first LV cable towards street center line up to first MV cable. If the number of LV cables are more and not having enough space available between the first LV and first MV cable, 3 to 5 meter space, then we can utilize the space spare area between first LV and parcel to draw the additional cables. Picture 8. Case 2, street row width is less than 10 meters. Digitize first LV cable at 3 meters distance from parcel boundary. Additional LV cables will be digitized next to first LV cable towards street center line up to first MV cable. If the number of LV cables are more and not having enough space available between the first LV and first MV cable, then we can utilize the space spare area between first LV and parcel to draw the additional cables. Picture 9. Select the LV-UG segment with respect to secondary voltage of transformer for digitization as showed in picture below. Picture 10. Notes. When there is difference between as-built base map and latest base map, SEC recommended to follow the latest base map and draw the lines accordingly. Crossing of UG cables are allowed when the connection bends are as per the internals of mini-pillar and LVDB. Any new cable found from the latest as-built will be drawn down to the existing cable. These new cables are allowed to cross the existing cables. Underground joints. Underground joints for both MV and LV networks are captures as per the SEC inputs, as-built, provided only, and there will not be any additional joints placed. Estimated path digitalization. We observed there are many locations SEC provided inputs are not sufficient to complete the underground network and all the connectivity details are not available in the provided as-built/hard copy maps. In these cases, we will draw the underground network lines with estimated path by referring to the source of supply numbers written in the LVDB areas, mini-pillar, meter boxes. In many of the cases, SEC provided as-built not proving 100% connection details for meters to mini-pillars/substations. Therefore, to achieve the maximum possible fully connected distribution network, we need to capture some of the underground cables by using estimated path. In these cases, we identify an identical/appropriate route for the cable by considering the shortest route and the availability of circuit connection details in the LVDB, mini-pillar boxes, and in meter boxes as per surveyed photographs. First, complete network having SOS full details and follow the below order to complete the estimated path network. 1. SS hashtag, LVDB CKT hashtag, MP hashtag, MPCKT hashtag. 2. SS hashtag, LVDB CKT hashtag, MP hashtag. 3. SS hashtag, LVDB CKT hashtag. 4. SS hashtag. 5. NOSOS. Use the cable risers when there is clear evidence that particular service cable is connected to that particular SS hashtag. Make sure all the lines captured as estimated path should have data source as estimated path and should have the same estimated path in comment as well. Here are some examples shorted down to describe the procedures of estimated path. Case 01 SS hashtag, LVDB CKT hashtag, MP hashtag, MPCKT hashtag. In the meter box, when we have the full SOS details as SS hashtag, LVDB CKT hashtag, MP hashtag, MPCKT hashtag, we can clearly identify the source from which circuit of that particular mini-pillar connected with this EDSP, and we need to use the appropriate route to connect this MP circuit. These cases are very much straightforward and to be completed with survey photos evidences that there is available free circuit, must be connected with cable, in the mini-pillar with cable connected. Case 02 SS hashtag, LVDB CKT hashtag, MP hashtag. When we have SOS detail as SS hashtag, LVDB CKT hashtag, MP hashtag, we can only identify from which mini-pillar this EDSP is connected. Therefore, we can use any of the free circuit, must be connected with cable, in the mini-pillar to connect the meters as there is no specific circuit hashtag. Mentioned, but we should be using only the use circuits as per survey photo, and we need to use the appropriate route to connect this MP circuit as depicted below. Underground service connection from mini pillar to meter, since the meter box have the same mini pillar number but there is no route available from as built, so it is connected from nearest mini pillar with the same number as mentioned in the meter box. Case 03SS hashtag LVDB CKT hashtag. When we have SOS detail as SS hashtag LVDB CKT hashtag, we cannot identify from which mini pillar this EDSP is connected. Therefore, we can use the specific circuit from LVDB to connect the meters as per the UG network connections available nearest to the EDSP. Make sure that we should be using only the used circuits, must be connected with cable, as per survey photo. Case 04SS hashtag. When we have only the SS hashtag as SOS, then we need to connect the next available mini pillar or the cable riser as per the SS hashtag low voltage circuits running nearest. Below depicted picture shows the underground distribution connection from PMT to mini pillar, which is from as built, but the meters doesn't have any route from as built, so it is connected from nearest mini pillar. In addition, the meter box source of supply only having substation number. Picture 12. Below depicted picture shows the underground service connection from cable riser to meter, but the meters doesn't have any route from as built, so it is connected from nearest cable riser. And the source of supply doesn't have substation number. Picture 13. Case 05NO SOS. When we do not have any SOS details in the meter box, then we need to look for the next available mini pillar and is there any free circuit in it for connecting this meter box. As second choice, when we do not find any mini pillar nearest with free circuit as per survey photos, then look for the free cable risers available in the nearest poles to connect this meter box. As third choice, check for any nearest PMT has free LVDB circuit connection which can be considered to connect this meter box. As last choice, we can check the nearest other type of SS such unit SS, package SS, room SS to make it use of their free circuit available. With survey photograph evidence, we have to make sure the network nominal voltages MV/LV are appropriate when we work with estimated path. None of the estimated path should be created without proper support of survey photo providing the confirmation of a cable going from LVDB, mini pillar can be connected to the nearest meter box. In the same MV network, estimated path also can be created based on the SLD support and the survey photo evidences. In MV we need concentrate on the switchgear and RMU evidences to connect each other with other supporting evidence from MV cable risers as well. In the below depicted picture, underground MV connection from substation to pole/MV cable riser, but the substation doesn't have any route from as built, so it is connected from nearest MV cable riser. Picture 14. Network connectivity. Digitized network connectivity should completely resemble with as-built data. Make sure to connect the exact circuit based on survey data and as-built. Mini pillar feeder circuit and LVDB circuits connection should exactly match as built with respect to their substation number and mini pillar number. Drop an issue point mentioning the missing entity in comment for any missing in survey data but present in as built. Merge the required segments for maintaining network consistency without any hanging segments. LVDB connectivity. Picture 15. Mini pillar connectivity. Picture 17. Meter connectivity. Meter connectivity done based on the reference from as-built data and estimated path. Make sure to connect the relevant circuit properly. Picture 18. Additional notes. We are not capturing cable risers for the cables that are directly connected to LVDB. Need to connect OH cables directly to LVDB. Refer, Picture 20. Need to maintain a 0.2 m gap between all risers. Refer, Picture 21. We have placed all the cable risers with proof of survey photographs only. When we found there some cable risers are not connected with subsequent UG cables, as there is no proper evidences for the connected cables. Therefore, we have kept the cable risers without connecting to UG lines. We have used the subtype MV cable riser when there is connection between MV OH and MV UG network. We have used the subtype LV cable riser when there is LV-UG network distribution line connected to the OH distribution line. If cable riser is available at dead ends and the OH distribution network continued by UG network, we have used cable risers to join the OH and UG network's electricity flow. We need to capture these types of DPDs that are clearly visible in survey photos. Refer, Picture 22. During the production, if we found any missing survey data or any missing features in as-built and available in survey images, need to report it. For the poles, we have used subtype OC13S all MV poles and subtype LTP for all LV poles and used WLTP wherever the distribution cable taken a support from a building wall. As per our project, requirements have updated the pole height as 13 meter for all MV poles and 10 meters for LV poles. All attribute field required for each feature class will be filled with respect to the mandatory field Excel. All attributes for assets are transferred from the survey data and only the additional attributes available in as-built/other sources will be captured. Any mass population required will be done in this attribution stage. Verify and update if any attributes necessary as per project requirements. Update the comments field of each feature class, when required, with the proper remarks which needs to be shared with SEC. Need to update source and sync for all captured cables. Refer, Picture 23. Update subnetwork ID for all LV-UG cables with corresponding breaker number of fuses in substation. Refer, Picture 24. Update the subnetwork ID for all the fuses in substation with their corresponding breaker number. Update the circuit number for all LV-UG cables with the breaker number of the corresponding fuse in distribution box. Note, the circuit number for the input cables from substation should be A or B WRT their connection.